Welcome to The Explainer. Today, we are diving into a world you've probably never thought about, the hidden data that literally shapes the quality of every single product you use. Yeah, I'm talking about everything from your coffee maker to your car. So let's start with a feeling we've all had. You get something new, you're excited, you unbox it, but it just doesn't feel right. Maybe it's a little flimsy or it breaks way sooner than it should. You're left wondering, what is going on behind the scenes? Why isn't this better? Well, this visual gets right to the heart of the problem. You see, when companies test new products, they generate a mountain of data, an absolute mountain. And this is the crazy part, often only a tiny, tiny pebble's worth of that information ever gets used to actually make the product better. The rest of it just gets lost. So let's dig into that. The way most companies handle their lab data, well, it creates a state of what you could call data chaos. And that chaos directly impacts the quality of the things we all buy and use every day. This data chaos isn't just some abstract idea. It boils down to three huge, critical problems that are happening right now in product development labs all over the world. First up, data just gets lost or forgotten. I mean, think about that. It's collected for one specific test, a simple pass or fail, and then it's basically abandoned. It gets buried in a report or just left to rot on a hard drive somewhere, never to be looked at again. And this has real, tangible consequences. An engineer designing a new coffee maker might end up choosing a less reliable water pump because they have no way of finding the test data from a model they made 5 years ago. Or think about an EV bike. The designers can't pick the safest, longest-lasting battery because all that critical performance data is scattered everywhere. In both situations, incredibly valuable knowledge is just wasted. The second major problem is that learning is, well, severely limited. For a lot of companies, testing is just about getting that green check mark. It's about a simple pass. It's not about really pushing the product to its limits to truly understand it. So what does this pass-fail mindset lead to? It means we get products that just meet the minimum standard, but they don't really excel in the real world. That coffee maker might pass a basic temperature test in the lab, but the coffee it makes at home is totally inconsistent. That EV bike motor might pass a power test, but it struggles the second you try to go up a steep hill, because no one ever pushed it that hard during development. And all of this leads us to the third big issue. Problems are found way, way too late in the game. They're not found in the lab where they're cheap and easy to fix. Nope, they're found by customers, by us, after the product has already been built and shipped. And you know, the frustrating part is that the warning signs are almost always hiding in the data. These subtle patterns, sometimes called data signatures, could have predicted the pump failures in those coffee makers or the overheating motors in the EV bikes. It's like the data was trying to scream a warning, but nobody was listening. And the result? Costly recalls, angry customers, and a damaged brand. Okay, so what's the solution to all this chaos? Well, it's not just about getting some new software. It's about a completely different philosophy, a new way of thinking about how you test products in the first place. And that new philosophy is called the test-to-learn vision. The goal here is pretty simple. Stop just checking boxes. Start building a deep, data-driven understanding of how products actually work, how and why they fail, and, most importantly, how they can be made so much better. This whole vision stands on 4 key pillars. First, you have to enhance the data you're collecting, get richer, more insightful information. Then, you standardize and centralize it so everyone can access it, not just one engineer on one team. After that, you use powerful tools to analyze it and find those hidden patterns. And finally, and this is so important, you add context or metadata so that 5 years from now, another engineer can look at that data and know exactly what they're seeing. And the real magic of doing all this, the power of that advanced analysis, it lets you shift from being reactive, fixing things after they break, to being predictive. You start finding problems before they ever happen. So let's go back to that EV bike motor. An analytic system could be trained to recognize a very specific vibration pattern, that data signature we talked about, that means a bearing is starting to wear out. So as the vibration gets a little worse, and then a little worse again, the system can flag it for the engineers, allowing them to fix the design long before it ever becomes a real problem for a customer out on the road. So why should you care about all this? What's the bottom line for us? Well, the payoff is simple. Smarter data leads directly to fundamentally better, more reliable, and more innovative products for all of us. You're really talking about a move from one world to another. You leave behind the old way, where knowledge is lost and problem solving is always reactive. And you move to a new way, where knowledge builds on itself, where you can predict problems, and where product designs go from being just good enough to being truly robust and innovative. And making this leap, this transformation from the old way to the new way, it delivers 4 huge, tangible benefits. And these benefits, they really touch every single part of the process. You get much higher quality designs because you finally understand a product's true limits. You get those products to market faster because you aren't wasting time with redundant tests. You build this incredible, lasting library of knowledge that makes every future project smarter right from the get-go. And you even get higher quality out of the factory. It's a win-win-win. At the end of the day, it all boils down to this really powerful idea. True quality isn't something you can just inspect for at the end of the assembly line. It's not an afterthought. It has to be designed and engineered in from the very first sketch, using data as your guide every single step of the way. So that leaves us with a final thought. The next time you pick up your phone, or start your car, or brew a cup of coffee, remember that its performance and its reliability were shaped by a hidden data story. And the real question is, how good was the storyteller? Because that makes all the difference.